Now, we've talked a little bit about censorship circumvention tools, but those circumvention tools themselves can also be blocked. And so many of these tools need some way of obfuscating their own traffic to make it more difficult for sensors to detect and block the use of those tools. In the case of Tor, this technology is called Pluggable Transports. In this part of the lecture, we will explore different types of pluggable transports, the different ways of obfuscating circumvention traffic, and we'll talk about a specific pluggable transport called domain fronting. Deep packet inspection can allow a sensor to discover and block the traffic associated with circumvention tools, including tools like Tor. The solution to this problem is to make the circumvention traffic look like something else, either by randomizing it or by making it look like another protocol entirely. Tor calls this particular approach to obfuscation pluggable transports, and there are 4 currently deployed pluggable transports that you can see here. OBFS4 and ScrambleSuit use randomization as an attempt to obfuscate the Tor traffic, whereas Meek and format transforming encryption try to mimic some other aspect of the protocol or use some other type of indirection to trick the sensor into thinking that the traffic is something else. Meek uses a technology called domain fronting. To understand domain fronting, it helps to understand the structure of a packet for encrypted web traffic. Deep into the packet, in the gray area, is HTTP data, and inside that data is something called a host header, which allows the web server to identify which web server or host this traffic is destined for on that particular machine. But outside that layer are a couple of fields that are unencrypted and visible to the sensor, in particular the IP address and the server name indication, which is visible in the TLS handshake. By directing the packet and the handshake towards the web server with the corresponding IP address, a sensor might think that it knows where this traffic is destined. But in reality these days, web servers tend to host multiple websites, and so one could direct traffic towards a web server, making it appear as though it's destined for one website, while in fact, inside the encrypted HTTP traffic is actually a host field indication that this traffic is destined for another website on the same machine. It's easy for servers, in fact, to disable this if they so choose, and sometimes it's viewed as a security vulnerability. The server itself could notice that the host header and the server name indication field don't match, and in so recognizing that anomaly, they may choose to discard the traffic. Google and Amazon have chosen to do just that, rendering domain fronting not effective, making it impossible to use domain fronting to reach websites that are hosted on these platforms. They've done so in the guise of improving security and defending against malware, but of course the side effect is that this pluggable transport may not end up working in practice for sites that are hosted on these content delivery networks. For this reason, Tor makes use of multiple pluggable transports. Domain fronting is of course useful for websites that are hosted elsewhere, and so it is used not only by Tor, but also other proxy networks and secure messaging applications. In summary, sensors can themselves detect and block circumvention tools, and so the tools themselves also need ways to obfuscate or disguise parts of their traffic that are most identifiable. To this end, Tor has a suite of so-called pluggable transports that provide this functionality. But the pluggable transports themselves can of course be blocked, and this is hence not a panacea, but yet another tool that can be used in the cat and mouse game between sensors and those who would try to evade blocking, circumvention, or information control.